So it's very nice to hear that also in Poland they are really starting with a national program, and it is even noticed by government. So congratulations, we thought. I think that's great. So also some updates from what we are doing. So we are a very small country, only very few people living in our country, only 18 million people. So everything we do is not so great as in the US, of course. So our institute, although, has also quite a lot of relationships all worldwide, especially in China. So we have data sets from the Nelson study, as you probably are aware of. So that's one of the studies we managed. Also the Rubinska study, which will be also addressed in this meeting. The Nelson B3 study, that's a collaboration between the Netherlands and China. And the foreign learner study, which will be, many results will be shown in this conference. We have more data sets where we are working on. So all those data sets are important for validation. And that is where we are focusing on with this institute, on the validation of all the processes of the big three diseases in one test, to optimize the functionality and also to more or less standardize the outcomes. So we focus on data acquisition, processing, post-processing, decision algorithms, data integration, image biomarkers, the development of those imaging biomarkers and also the validation of those. And then very important in our view is the workload reduction. So the workload reduction is probably key for the implementation. As it is done in most countries at the moment, that is the real problem for implementation. Then also key to everything you do in lung cancer screening is the process monitoring, so that you know what you're doing in your program any moment in time, at any moment. And then report coupling of the referrals and the actionability of every findings. So if you have a finding, you should really go into, is it actionable or can it wait? And that is something that should be, I think, in the minds of everyone, that is a decision that has to be made. And then also very important is the AI validation itself. So we give also feedback to software developers. We test that, and we do that confidentially, of course. And from this, we hope that also the validation will help to improve those. So we will show something on this conference also, what the differences are, even on the easy point of the detection of every abnormality. So this is the foreign learner study. It's funded by the EU. It's in 6 European countries, and you see here the sites that are involved. It's from Germany, Spain, Italy, France, the UK and the Netherlands. I don't hope I forgot a country. So this is what we are addressing. We are focusing on what is the best cost-effective and reliable interval for follow-up in lung cancer screening. So we have a randomization in 2 arms, and we do a follow-up in one arm of 1 year and in the other arm of 2 years. And of course, what is the influence of the negative baseline CT? What is the impact of a negative CT? If you have no nodules at baseline, can you wait longer? Can you stretch intervals? Now, then furthermore, and I think that's also very important to realize, we focus also on the comorbidities. So that is the calcium score or the atherosclerosis in the coronary arteries, and of course also the emphysema. So recently, I think just this week, the FDA approved one of the first inhibitors of lung fibrosis. So that is really something that is going to be very important. And then, of course, the interaction between those 3. We will address that also in this meeting. Then here, this is the continuous monitoring that we are doing. So this is of March 16. There we have 33,000 CT scans in foreign learners scanned. We finished baseline and annual follow-up. and we are now in the 2 years follow-up in the biannuals. Furthermore, very important, you see that on the right hand, is the dose registry. Especially in Germany, the implementation is more or less dictated by the physicists that control the dose that is implemented for each center. And we are now able, from the information that is provided by what is more or less in the DICOM headers of the CT scans, to calculate the dose per participant and also summarize that per center. And here you see all the centers and the average dose per center, and you see quite a lot of difference, but not unacceptable. So here you see a difference from 0.5 or even lower, and now 0.5, around 0.5 to 1 millisievert. I think that's very acceptable. That's also what we focused on when we did the application. So altogether, I think you should not go lower with your doses, because then the calcium score becomes very unreliable. Now, what we are testing also in Fornelungen, and that was mentioned before, is the three different approaches of implementation. So one is the way you do breast screening. So that is the current practice. You have 2 radiologists, and if they do not agree, you have an expert panel, and then you define the final outcome. And if you have no answer, you would do a follow-up of 3 months, and then work out the final outcome in terms of lung cancer probability. And then the second one, and that is the Fornelungen workflow. We have one AI read, and we have one radiologist. If they do agree both, then we do not do anything anymore, so the participant will be automatically, when it's negative, scheduled to the next round. If they disagree, then we have a follow-up in the expert panel, and then there it is decided if what is needed, a 3 months follow-up, or that you can go to the next round, or that it is indeed negative. And what we are now focusing on is that we have AI as a first reader. And having AI as a first reader is not that simple. Then the whole discussion of incidental findings comes in, which is a big discussion in England. And I think that is all addressable, but it should be proven. And that is what we just published, histological proven AI performance in the UKLS data. That's one of our data sets. There you have a very well described data set for validation with real outcomes in terms of histology. And there we could prove that there is big potential for workload reduction by AI as a first reader. So we concluded that the implementing of AI as a first reader to rule out negative CT scans, and it can go up to 70% or higher, shows considerable potential to reduce CT reading workload and does not lead to missing lung cancers. Now, that will be also in a presentation in this meeting. Then we also recently published the validation of nodule growth rate as a new imaging biomarker. And this VDT assessment performance in follow-up screening outperforms human readers. So that's also very important to know and will be addressed also in this meeting. Then furthermore, are we working on the calcium score? That is also something we will address in this meeting. Is it reproducible? And is it also able to show progression? Then important is also that we do a comparative analysis of the detection of emphysema, and that is very difficult to develop, because in an overview, systematic review, we found that there's a very poor agreement between emphysema measurements by the local area attention that's the way we do it all, with this threshold of minus 950 Hounsfield units, and then that quantification and compared with visual scores, and there is almost no agreement between the radiologist and the quantification that is provided by the CT analysis itself. So that there is a lot of work to do, and that is what we are doing with further work on the cluster analysis of the lung, by which we hope that we can reduce the random noise clustering that can go up to even 5 millimeters. So then there is no emphysema, but you have a random noise clustering, especially with the protocols that we use for the acquisition for early detection. And here you see that the optimal correlation between visual and cluster detection of emphysema is around the 6-7 millimeters. So that is something we are working on. Now, very, very important is for the implementation as AI as a first reader, is that we found over the first years that only vascular findings could lead to immediate action. All other findings can wait, probably. So that's where we are working on. And therefore, we are developing a baseline implementation on non-contrast CT segmentation of the aorta. And you see here two. This is one patient from baseline. And there was an aortic ascending aneurysm detected. And after 1 year, you can see it was reported. The patient was operated on. And you can see here the prosthetic replacement after 1 year. And the participant was just staying in the screening. So that's also, I think, quite interesting. Now, we are also working on the validation of other, all kinds of different softwares. And this is an example of one of the softwares that we are working on. And here we found that there's a lot of examples of off-target heat maps which appear as a functional nuclear imaging tracer map. And you see here that the nodules, the lung cancer, proven lung cancer cases, are not in the field where the heat maps are coming up. And they more or less mimic also in the PET-CT scan in a manner that I think it's quite, it's deceiving more or less the radiologist. So this is for the introduction of the meeting. I hope I could bring up your curiosity a little bit to focus on early detection. Thank you for your attention.